Hello, problem solvers. This is lesson 17 about inequalities. This is deviates some from the text because the text focuses on the AM-GM along with the Cauchy-Schwarz inequality. We're going to skip that and we're going to focus on the triangle inequality because I'm trying to prepare you guys for advanced calculus. So first, this example is an algebraic manipulation example, and there's an important piece of this that if you look at this proof, what they're doing, they're saying, hey, this inequality is true at the top, which is actually, this is the AM-GM for two elements. And they're proving it by squaring both sides, multiplying both sides by 4, and then FOIL, and then subtracting, and then getting something that's always positive because it's a square. All of those steps are reversible. You can, so I could FOIL out that thing at the bottom, and then I can do subtraction and addition and factoring, and all those things can be done both ways, and so that maintains the inequality. What you can't do is start with an inequality, multiply both sides by 0, get 0 is greater than or equal to 0, and say, hey, the original thing was true. Every algebraic move was something that they could do again. Now, at the top, they square root both sides, but if you have positive things and you square root both sides, that stays true. That one's a bit more subtle. But in general, if you're going to do an algebraic thing like this, make sure all the algebra steps are reversible. Okay, so that was one case for n equals 2 for this inequality, which is called the AM-GM. Arithmetic mean is the average that you're used to. You add up all the numbers, you divide by the number of numbers, divide by n. Geometric mean would be you multiply them and take the nth root. The arithmetic mean is always greater than or equal to, and they only match up if all the numbers are equal. So in general, the arithmetic mean is going to be more than the geometric mean. And the trick for this is often just trying to recognize how you can cleverly mess with a problem and make it look like this inequality. Here's an example. They're trying to show that this crazy expression is greater than or equal to 4. You have positive numbers and you have a plus b times the quantity 1 over a plus 1 over b. And so what they did was first they just multiplied that out. That seems like an easy first step to simplify things, and then get rid of the constants. And now you have a over b plus b over a. Well, if you look at that carefully, they kind of skip a lot here, but look at that third line carefully, and you're adding two numbers. So the average of those numbers you divide by 2. So imagine on the left side that has a 2 on the bottom. Then the geometric mean, well, those two numbers are reciprocals, so the geometric mean would multiply to 1, and then you move the 2 back. So you have to fill in some steps there. There should be a little bit more there, but think of on the left, think about if you took those two numbers that are being added and averaged them arithmetically and you average them geometrically. If you get out pencil and paper and write that down, you should see the answer. And then the rest of it is going back up algebraically to the original. Okay, so the triangle inequality is about absolute values, and I'm finding that students really struggle with inequalities that have absolute values in them. So I want to focus on this for a minute. Absolute values definition technically is piecewise. It's the function when it's positive, but it's the negative of the input, or maybe not function, but the number input. If it's negative, you reverse it, you multiply by a negative to fix it. The triangle inequality just says if you're adding two absolute value numbers inside the absolute value, it's less than or equal to if you did them separate. If you think of x and y as vectors in R2 or R3, it's the equivalent of the tip to tail type addition that you do in like linear algebra and in Cal 3, and then that's where the triangle is coming from in the expression. Reverse triangle inequality is that when you subtract, it's actually greater than or equal to, but notice that you've got a lot more absolute value signs, so look at that one carefully. And then on the bottom, there's an example of a problem to try